Hello, my name is Titus North. I'm the Executive Director of Citizen Power, and today we're going to have another one of our presentations on energy as part of our teacher training workshops. Today's presentation is on energy conservation and efficiency, and the title of the presentation is Students and Teachers Making Schools Energy Smart. Americans use about 3 times as much electricity per capita as we did in 1960. And the United States, of course, uses more electricity per capita than any other country. We use as much as 25%. China is increasing its energy consumption, but still on a per capita basis, the United States is head and shoulders in front of the rest of the world. Now, if you think back on your house when it was built, maybe my house is 100 years old, and your house might not be that old, but if you're living in an older house, you know in many of the rooms, many of the bedrooms in particular, there might only be 2 or 4 electrical outlets, and nowadays that just doesn't suffice. So we have power strips and extension cords running all over the rooms to plug all our various devices in. We have so many more devices now that require electricity. If you think of our various computers and Game Boys or game devices and things like that, it's just a lot more electricity usage, a lot more appliances. Now, some of that gets offset by increased efficiency. In particular, refrigerators are more efficient. They're one of the biggest electricity users in the household, but they've become much more efficient in the past 25 years. And then also stereo equipment, which used to use quite a lot of electricity, has been replaced by very small and energy efficient iPods and things like that. Now, our known sources of energy, such as oil, coal, natural gas, are limited. Now, we had been saying, say, 50 years ago, we were worrying about these resources running out. What's happened, of course, is rather than running out, what we knew about back then has been largely used up, but we've found new resources, but in much harder and more dangerous to obtain locations, such as beneath 2 miles of ocean water, or in the Arctic, or locked up in shale formations. And so they're more expensive and more dangerous to reach. And then, of course, nuclear power is uneconomical and has its own sets of risks, as the Fukushima meltdown is making very clear. So our energy costs are rising. Now, the best and cheapest power plant you can build is the one that you don't build. In other words, if we increase our energy efficiency and conservation, we don't need to build that very expensive new plant. That's why we should be moving into energy efficiency and conservation. Of course, we need to develop new sources of energy, and especially the renewable sources such as solar and wind and geothermal. But if we're going to close the gap between our consumption and our resources, probably the biggest factor has to be using the energy that we have more wisely. So energy efficiency and conservation, it offsets our increased energy usage. It prevents having to build costly power plants. Even though some of the technologies might have higher upfront costs, think of compact fluorescent light bulbs. They save money overall, and you can think of how much money you might have saved. I know how much money I've saved from compact fluorescence over the years. Often they're better technologies anyway, and think of the reason that the efficient MP3 players have become so widespread is they're a lot easier to carry around than a giant boombox. The increased efficiency and conservation will protect the environment and reduce greenhouse gas emissions. And often they open up new industries with lots of jobs. And of course, it promotes national security by decreasing demand on foreign sources of energy. You don't have to send the 7th Fleet off to the far corners of the Earth in order to protect energy that you're not getting anyway. And we don't need the energy if we use the conservation. Now, what can we do in schools? We call this section EnergySmart Schools. Well, 1 out of 5 Americans, 20% of America's population, spends their days in schools. We have 55 million students, another 5 million faculty, not to mention the other workers in schools. Schools are typical of buildings, the homes and commercial buildings and industrial buildings. They have the same types of requirements as schools have for the most part. Buildings use a great deal of resources. They account for 12% of our water usage. They make up 39% of our carbon dioxide emissions, 65% of our waste output, and fully 71% of our electricity consumption. Energy use is the second biggest operating expense for schools. And what do you think the biggest expense that schools face is? It's, of course, labor expenses, our salaries, so teachers and administrators and janitors and whatnot. So the more that we are able to conserve energy, the less we have to spend on our energy bills, and that leaves more money left over for our salaries. American schools spend $8 billion a year on energy, and 25% of these costs could be saved. We could be avoiding these energy bills through better design and better efficiency. And also, by employing more efficient energy measures, schools could serve as a model. And of course, the students would bring home a lot of these lessons, and they could be replicated in their households. How many of you have heard of green buildings? Green buildings use resources more efficiently and reduce a building's negative impact on the environment. This is done through design process. Green buildings, you don't have to build an entirely new building. Buildings can be retrofitted and renovated to be green, but you have an integrated design process. There's thought put into the planning, the landscaping. We'll be hearing more about that. Building an envelope or a shell for the building in order to conserve heat and prevent heat loss. Better mechanical and electrical devices, and non-toxic finishes to make sure that not just during the lifetime of the building, but even after the building has been torn down, that you're not going to be putting in a lot of toxicity into the environment. And thought is put into reducing the waste stream. So green buildings, they save money and energy in the following ways: by reducing energy use, reducing carbon emissions, reducing water use, and reducing solid waste. So you have green buildings, and then the next step up from that would be a net zero energy building. So a building that produces just as much energy as it uses would be a net zero building. Sometimes it might be using more than it produces, and sometimes vice versa. If it produces as much as it uses, then it's a net zero building. Here's a picture of a net zero building from Seattle, Washington. And you can see the solar panels on the roof. That would be doing a lot of the energy production. It can also, you're not typically going to put a wind turbine on one of these buildings, but you would be producing electricity either through the solar panels, or you might have solar hot water heating. That looks like it's a solar hot water heater. And it may also use a geothermal heat pump. And then also the design is such that it's going to prevent heat loss. It's going to be water. It's going to conserve water, because water is, when you use water, you're using power. Now this looks very futuristic, but here we see right here in Pittsburgh, Pennsylvania, some net zero buildings that look like many other buildings you would see in the neighborhood that don't particularly stand out. So a net zero building need not look like a futuristic building out of the Jetsons. Now, this is an example of some of the components that go into a net zero building, a net zero energy building. Here's a home, and you'll see here it's got insulation all over the place. So it's got insulation under all the living spaces. It's got a geothermal, well, it's got a heat pump, and it's a geothermal heat pump. Now, a heat pump moves heat rather than producing heat, and they work very well when there's not a very large differential between the place that they're taking the heat from and where they're moving it to. Heat pumps have been used extensively in the southeast of the United States where there are mild winters. A regular heat pump doesn't work too well in climates like Pittsburgh because the winters are too cold, and the temperature differential between the inside of the home and the outside is great. But this can be overcome through using geothermal. If you, in this case, a 450-foot deep well was drilled in the home or under the home, and pipes were put down, and these pipes are going to be ground the same temperature as the ground, as the underground, which might be about 55 degrees Fahrenheit. And so the differential between the 55-degree ground temperature and the building temperature of about 70 degrees or 72 degrees is not great at all, and a heat pump will work very efficiently with that type of differential. You see all sorts of other things. So there's more insulation here. You have EnergySmart light fixtures, insulation on the roof. You have a photovoltaic solar array on the roof. Here's another feature, the white reflective roof. So where you don't have the solar arrays or other infrastructure, painting the roof white will minimize the heat gain during the summer. And so it's a very good way of reducing your air conditioning bills. These are some of the various features of a net zero building. Now, how about achieving this type of energy savings in the school? Well, let's look at schools. What do schools use their energy for in the first place? You'll see over here, space heating is the number one energy requirement in a school. Almost half of the energy is going towards heating, and then depending on where you are, space cooling and ventilation is going to be another large factor. Now, if you're in Florida or Southern California, that's probably going to be larger than space heating. But in most of the country, especially seeing as kids are out of school in the summer, space heating's number one. You have lighting is a big, especially in terms of electricity, lighting is a big energy usage. You have water heating, and then various electrical appliances. By looking at all of these and looking for where you can get efficiency, you can save money. This can be done through replacing energy systems or replacing hardware that uses energy, but it can also be done by changing behavior patterns, and that costs nothing to fix. And students can be involved in this. As a matter of fact, Citizen Power has been lending out free of charge energy audit toolkits to schools. We have a program, and so you can look on our website to contact us about how to get one of these kits sent out to your school for free. Students that have borrowed our toolkits have done all sorts of things, and they have found things like leaky air ducts inside of walls that were leaking hot air inside the walls, therefore wasting a great deal of energy and money. And they've had the school maintenance people fix these problems. it's something that's very interesting for the students because they can learn about the energy, they can learn about how to do these things, and they can really make a difference. So conduct a energy audit, for instance. This can help you estimate how much money and how much energy you might be able to save if you make certain changes. You can propose changes to your school, and we've had other cases where the students have been able to help get motion detectors put in schools or other types of energy efficiency improvements. You can set up teams that will monitor recycling or energy usage. There's a school around here in Pittsburgh where personnel is assigned to go around in the classroom at the end of school and make sure that lights and computers are turned off. And you can have an awards program to recognize those people who make contributions towards energy efficiency. So for room temperature management, if you have, you might have at your school thermostats that cannot be regulated by the teacher, and if that's the case, it's a shame. We have one of our teachers that we're familiar with actually broke into his own thermometer, his own thermostat to regulate it, but he was near retirement and didn't really care if he got caught. It's not necessarily the thing that everybody wants to do. But what are some of the things that you can do? If you have an individualized thermostat setting, you might be able to program your thermostat so that you're not wasting energy heating up the room overnight. You can have ventilation controls. Operationable windows where you can actually raise the window sash and bring in the air if you need it. That can be an energy saver. And the same with blinds. If you can use blinds to bring in sunlight and use less of your overhead lights. Ceiling fans if you have them. Opening and closing doors when appropriate can be important in conserving energy. The way your room is arranged and the scheduling for when you're using rooms. If you are using a room just once in a day and having to heat it up just for that one session, it might be good to think about using a different room instead. One of the tools in our toolkit is a simple magnetic pocket compass, like you might have used in the Boy Scouts. It's important to know where north and south is. The southern windows are where you're going to get more light coming in. It's also the southern walls that are going to be heated up by the sun. And sometimes you want to be heated up and sometimes you don't. Okay, well here's a typical house. It has a lot of the same features as a school. And this graph here, it shows you the various areas where heat can be lost or cold air can be let in. And some of you may have noticed that actually your electrical outlets sometimes let in a fair amount of cold air on a winter day. They can be simply plugged up when they're not in use. You have all sorts of other areas, and some of these are unavoidable. You do need, your dryers needed to be vented. You have to have plumbing vents. But other areas can be insulated better. If you have recessed lighting, you have to make sure that you have appropriate insulation so you're not losing heat. Of course, one of the most important areas that you can do something about is around windows and doors. So underneath the doors, you can a very simple device that anybody can make is a door snake. You can use old stockings or socks or other types of fabric and stuff it and put it just lay it right on the bottom of the door, and that's a lot better than nothing. That keeps out a lot of the cold. And then caulking around the windows and doors can keep out a lot of cold air. The next device that we're going to talk about is the digital infrared thermometer, and this is a lot of fun, and kids like it. It's almost like the phaser gun from a Star Trek episode. It shoots out a little laser. Now that laser has nothing to do with the actual temperature measurement process, but it does show you, it's basically just a laser pointer. It shows you where you're pointing it at. But there is a hole on the other end of this thermometer, and it lets in the infrared light, and based on the what part of the infrared spectrum is being let into the measuring device, it will measure the temperature. And so you can point this up at ceilings, or the corner of a wall, or you can point it at windows, and you can find what the temperature is. And it was using this piece of equipment that the students found the broken air duct behind the walls. So you can measure the temperature of walls even in places where your hands wouldn't reach. So it's good for spot or long-term or long-range temperature taking. And it's good for finding temperature differentials in drafty areas. You can find where the floors are particularly cold. So it's a very fun and useful piece of equipment. And once you've identified the leaky areas and the cold areas, you can go to it with caulk. Now, we don't expect that your students are going to be doing the caulking, but of course this is something that a homeowner can do, and certainly the maintenance people at a school can do it as well. So caulking and weather stripping is important for this. This is not part of the Energy Audit Toolkit, but a programmable thermostat in any house or any room that has individual heating is an important device. What you can do is you can set one temperature for the nighttime hours and another temperature for the daytime hours. So when people are going to be awake and about, you can have it heated to a comfortable, heated or cooled in the summer to a comfortable temperature. But certainly when you're asleep in the winter, you don't need to have it as hot, and you can let you can program the thermostat so that it will be cool while you're sleeping, and then it'll automatically heat up when you're getting ready to wake up. And this is called a setback. And a rule of thumb: for every degree that you set back your thermostat at night, you can expect a 1% savings on your fuel bill. So if you're going to set your temperature back by 10 degrees overnight, that's a 10% saving on your fuel bill, and in some parts of the country that can be very significant. Now, some people think that it actually takes more energy to heat up a house again after it's been cooled down. And that's not true. Actually, when the temperature is lower, it means there's less differential between the house on the inside and the temperature on the outside. And the smaller the differential between the inside of the house and the outside of the house, the slower the heat loss, the lower rate at which you are losing heat. So it does make sense to set back your thermostat. The only situation where you wouldn't want to do it is if you have a floor that's heated. So if you have pipes that are running through your floor, and this is not very common, but some geothermal systems have this, where you have the pipes running through the floor and the entire floor heats up. The floor heats up and cools down so slowly it can take a day or two, so that setting back your temperature for 8 hours at night really doesn't make sense. Okay, here's the next piece of equipment. This is a digital hydrometer, and this measures the moisture level in an area. You want to have, in general, relative humidity between 40 and 60%. Okay, so this is low enough that it's not going to produce a lot of mold. It's not going to encourage mold to grow, but it's high enough so that the sinuses don't get dried out. You want to have somewhat lower humidity in the summer. The lower the humidity, the easier that your perspiration will evaporate, and that makes you feel cooler. It's the opposite in the winter. You would want higher humidity in the winter. And so this is something to think about, for instance, when you're ventilating your bathroom. If you take a shower in the summertime, you want to make sure that the windows are open, or if you have a ventilation fan, that you're using the fan so that humidity does not go inside the rest of the house. On the other hand, in the wintertime, the steam from your shower can help raise the humidity inside the house. So in the wintertime, you wouldn't want to use your ventilation fan if you have one in the bathroom. Now, water usage means energy usage. It takes energy to pump the water from the source, to treat the water, and then to pump it into your house. It all takes energy. So you want to conserve water as a means of conserving energy. This means making sure you don't have drippy faucets and pipes. You want to make sure that your toilets are running properly and they're flushing right. You want to make sure if possible, that you're using low-flow shower heads. You can conserve a great deal of water and have just as enjoyable a shower if you use the low-flow water heads. And you want to make sure that you have the proper water temperature. It's all too easy to have a very high setting on your water heater, and then when you turn on your shower, you just mix in a lot of cold water to get the temperature right. But that creates a lot of wasted heat. It's better to have your water heated to no more than 120 degrees. Outdoors, you want to make sure that you have the right type of vegetation around your building or your house. You can use mulch around plants and trees to retain moisture so you don't have to water them so often. And if you get into using rain barrels to collect water, that's a lot of fun, and it can save on your water bill. The next piece of equipment we have is the digital thermometer pen. This is something that's useful for measuring water temperatures. So lowering your water temperature by 10 degrees can save 5% in your water heating bill. So if you have your water heater set at 130 and you put it down to 120, you can expect a nice little savings there. The water temperature doesn't have to be hot for washing your hands. It just has to be warm enough so that the soap works properly. And of course, soap will wash off your hands better with warm water, but it's not as if you're using the hot water to sanitize your hands. It's the soap that does that. So 120 degrees is it's low enough to prevent scalding and high enough to prevent Legionnaire's disease. And next, the low-flow shower head, which I mentioned just earlier. A standard shower head would use 8 gallons per minute. So a 12-minute shower would use 40 gallons of hot water, your entire water tank often, if you have a 40-gallon tank. Whereas a low-flow shower head is only going to be using more like 2 gallons per minute. And if you can also try to take a somewhat quicker shower, that will also cut down on your water usage, and that will give you great savings. So the aerators in these low-flow shower heads provide a high-pressure spray, so you don't really notice the difference. You're using less water, but because of the higher pressure, it feels just as nice and warm. Okay, next let's talk about lighting. As you remember, lighting next to space heating was the largest energy usage in schools. Schools for a long time have been good at having the fluorescent lighting. So fluorescent lighting is pretty typical in most classrooms. But some areas, especially in the offices, may still be using old-fashioned lamps and incandescent light bulbs. Now, of course, if you're opening up the window and you're bringing in some daylight, that's your cheapest and most cost-efficient way of lighting a room. But this, of course, can be supplemented with fluorescent lighting, which is common, but also LED lighting is now it's coming down in price and has the promise of being even more energy efficient than fluorescent. You can use lighting controls. This can be occupancy sensors, and these are very useful in bathrooms, for instance, where most of the time nobody's there. Why have the light on in these rooms that are unoccupied? Dimmers can help. You can, if you don't need all the lights on for most of the things that you're going to be doing in a room. So you want to be conscious of how much light you actually need in a given work area. Timers, photocells, other things can help you conserve your lighting electricity. And we're going to be talking about lighting levels in just a second. So when you're thinking about this, you have to think about who, what, where, who, what, when, where, why, when you're thinking about your lighting situation. Okay, the compact fluorescent lighting, and this is particularly relevant for our houses. Houses today still tend to use incandescent light bulbs, but these compact fluorescent light bulbs, which have come down so far in price since their introduction in the 1990s, they've come down so far in price that there's very little upfront costs associated with them. And as a matter of fact, many electricity companies will send out free free compact fluorescent light bulbs to you if you contact them. They last much longer than the incandescent light bulbs, and I have a number of light bulbs in my house that I bought in the 1990s that are still shining quite brightly. Okay, well, as I mentioned earlier, most schools for a long time have been using fluorescent lighting. They use the old-fashioned fluorescent light tubes. And these tubes, you've seen them for ages. They've been around, but there are new types of tubes that are coming out. So the old-fashioned tube was 1.5 inches in diameter, and while they're much more efficient than the incandescent light bulbs, there are 1-inch diameter tubes that have come out more recently. They're called T8, 8/8 of an inch. They fit into the exact same fixtures, so you don't have to replace your fixture. You can just replace the tube, and they're 20% more efficient. There are even narrower light tubes called T5s. They're 5/8 of an inch, and they're even more efficient, but they require a different fixture. So these are great for new buildings, but if you're going to retrofit, then there's some upfront expense required in changing your lighting fixture. Along with the which tube you use, there's another issue, and that is the ballast. So the fluorescent lights use a ballast, and the ballast, the original ballasts were magnetic, and they flickered back and forth 60 times per second along with the electricity current. And this flickering, which caused the light to actually flicker on and off 60 times per second, was a safety issue in some areas. So in a shop class in school where they use drill presses, for instance, back in the old days, they would not have fluorescent lighting because of the flickering effect. If you had a drill press that was rotating at 60 times per second, it would appear to be standing still under a fluorescent light. That property of a magnetic ballast on a fluorescent light is what makes this flicker checker work. This is the way you can tell whether you have an old-fashioned and relatively inefficient magnetic ballast, or whether you have one of the new energy-efficient electronic ballasts. Now, these ballasts flicker on and off 10 to 20,000 times per second, which is completely imperceptible to the human eye. So you don't get any of that irritation, and of course none of our drill presses are going to be rotating that fast. So they're much safer in that way as well. If you take one of these flicker checkers and you spin it like a top, just spin it like a top, if you're under an electronic ballast, you just see concentric circles like this. If you're under a magnetic ballast, because of the placement of these little squares, and on the outside there's fewer squares, and each row as you get inside there's more squares, you see each one of these rings seems to rotate one way and slow down and rotate the other way. They don't do it together. Some are going one way, some are going the other way. It's an interesting optical illusion. You get a little bit of bluish tint, sometimes a little bit of reddish tint, and
It's hard to explain, but you will know it when you see it. So if you spin one of these under a fluorescent light and you get the effect I just described, you'll know that that's a magnetic ballast. And these can be replaced. Homeowners can do it if you like do-it-yourself projects. It's quite simple for an electrician to do, and there are schools who have gone and replaced all of their ballasts, and you do get a very significant savings. You can save as much as 30% on your lighting bill by switching from magnetic to electric ballast. Okay, I mentioned earlier there's another type of light bulb that's now on the market, and that's the LED light. So the LED light uses a light-emitting diode, and light-emitting diodes have been around for 40 or 50 years, and they last a long time. Now, the ones that first came out were red, and if you think of those old stereo equipment that I was talking about earlier from the 70s, maybe when you were growing up, and they had the red indicator lights. How many of you have ever seen one of those red indicator lights that burned out? It doesn't happen very often. So light-emitting diodes, they last a long time. Now, the reds came out first, and then they started getting other colors. And now they have white light. They're more efficient even than the fluorescent light bulbs. And they last a long time. Here's our next the next toy that's in the energy audit toolkit, and this is one of the most fun. This is a light meter, and you would be surprised at what you'll find when you use this light meter. Take this cap off, and there's a receptor, a light receptor, and you can place it on any surface. You can place it on the table, or you can hold it up close to a light fixture or light bulb, and this will tell you how much light is being received at this receptor. And you'll find, of course, that the closer you are to a light, obviously, the higher this number is going to be. One of the things that I found most surprising was walking outdoors with one of these. And you know, of course, it's brighter outdoors than indoors, but this will tell you just how much brighter it is. And because our pupils contract when we go outdoors, and we squint our eyes, we're actually able to shut out most of the light, and then our brains also process the light differently. But you'll notice that the brightness outside on a sunny day, or even on a cloudy day, is orders of magnitude greater than what's inside. And what we have found is that most schools are overlit. And the Erie School District was able to save a huge amount of money in some of its administrative buildings by removing a lot of the light bulbs from its light fixtures. They were so overlit. Another area where you can save is on outdoor lighting. Now, it's common in many places to have lights on around the school or around the building 24 hours. It's thought as a measure that will keep away crime. And to a large extent, that's a myth. The National Crime Prevention Council reported that dark campuses actually seem to deter vandals. If you're thinking of vandalism, maybe they need more light to see what they're going to do. And often they're not deterred by light because if they're there in the middle of the night, they figure nobody's watching them anyway. So thought should be given to which areas really do need to be lit at night. Now, another area is the way we use our appliances and when they're on and off. So let's look at equipment usage and plug load. Our computers and our computer peripheral equipment, we have them plugged in, and all too often they're left on all the time. They be left on overnight. The same goes for other things like copiers and office equipment. Vending machines are another big user of energy when it doesn't need to be used. So many devices today, even when they appear to be off, are not really off. And we call this the vampire or phantom power load. So when we're actually using equipment, it's on. And then often we turn it off, but it's not really off. It's in standby mode. So a TV might be drawing electricity simply so it will come on a little bit faster when you switch it on. And as a matter of fact, this phantom or vampire power load can use up as much as 5 to 10% of the total electricity that is generated in the United States. So what can be done about it? Here's something interesting. This is, we all have surge protectors in our house. This is a smart strip surge protector. And the way it works is you have one device that is plugged in here to the blue outlet. And when that device is turned off, it will automatically turn off the other devices that are plugged in. So for instance, if you have a television set and it's got VCRs and DVDs and DVRs and other equipment that are attached to it, when you're not watching TV, most of those don't necessarily need to be turned on at all. And so you can turn off the TV and it will automatically take the power away from the other peripheral equipment. This is also very good to be used with a computer. When you don't need your computer on, you don't need to have your printer on either. So this is one way of taking care of that problem. Now this is also a good device for your energy audit. This is called a kilowatt easy monitor. You plug this into the wall, and then you can plug an electrical appliance right in here. Turn on the electrical appliance, and it tells you how much electricity is being used. More than that, you can use these various settings, and you can calculate if you left this appliance on for an hour or a day or a week or a year, how much electricity would it use? And you can even program in the cost of electricity in your area, and it will tell how much money you are paying for that electricity. Well, how about computers? Computers are one of the main users of electricity nowadays. And what in the computer is using a lot of electricity? Well, the monitors use a lot. In fact, they use about half of the electricity of the computer system. And the bigger the monitor, the more it's going to use. So a 17-inch monitor is going to use about 35% more than a 14-inch monitor. And so you might want to think about what you're doing and what your needs really are, because bigger is not necessarily better. The laser printers, when they're on standby, you might think they're off and they're not using electricity, but they actually will use about 1/3 of the power when they're on standby. Now, laptop computers are designed to be energy efficient because they're designed to be used with batteries at least some of the time. And so they can be more energy efficient than desktops, although they can cost more, so there might be an upfront cost there. Now, leaving computers on overnight is something that's very common. A lot of people don't like to come in and have to reboot their computer and reload their programs. But actually, this practice of leaving computers on every night has been estimated to cost the United States $2.8 billion a year in electricity. You can translate that into carbon. It's 20 million tons of carbon dioxide into the atmosphere. A school district that has 500 computers could save $14,000 a year by turning off their computers at night. Another big energy waster that you'll find in schools is a vending machine, which have become all too ubiquitous in the cafeterias. When you think of a vending machine, what is it? Well, often it's a refrigerator with lots of lights and a mechanical device for moving the drinks around. All of these use a lot of electricity. Certainly, the lights can be turned off when nobody's in the room. And there are some devices that can be used with certain vending machines that will turn off that have motion sensors and or timers, and they will turn off the lighting when it's not used. And they can be shut down. There's no point in having a lot of cold drinks overnight or over the weekend when nobody's there to buy them anyway. We also want to think about our solid waste. So start off in the purchasing. If you're buying EnergyStar equipment or EnergyStar supplies, these are supplies that not only conserve energy, but went through a manufacturing process that was energy efficient. They will typically have recycled content. They can be composted. They're non-toxic. They minimize packaging. And if you can buy these things in bulk, if you can buy them locally, when you buy things locally, there's less shipping costs. And you can buy as a cooperative. How about recycling? What can be recycled? Certainly paper and cardboard, and there's a lot of that's produced in schools. There's plastic from the drink bottles, metal, glass, electronics, battery. Clothing can be taken to Goodwill or recycled in other ways, composting, and reusing wood. So there's all sorts of opportunities for that. Now, speaking of the plastic bottles and our plastic bags, these are very cheap to manufacture, but we don't think about how difficult they are to dispose of. So Americans are buying 31.2 billion liters of water in plastic bottles per year, and most of these bottles are not recycled. They wind up in landfills and oftentimes wind up in the water. Plastic bags and plastic bottles and other plastic items wind up getting into the ocean, and in fact there are these vortexes where the very slowly degrading plastic tends to accumulate. So in the middle of all the oceans, you have these areas that have high concentrations of plastic. Now, this is not actually an example of one of those. This is a body of water where there's a lot of not yet degraded plastic that's in a high concentration. That's not what I'm talking about. But but in these areas, you have little scraps of plastic that's floating around in high concentration, and while it may not be visible like this, it does interfere with the ecosystem, and it releases these toxic chemicals into the ecosystem, and it's becoming increasingly a big problem. These plastic items require a huge amount of petrochemicals to manufacture, so it's more than 17 million barrels of oil that are going into the manufacture, and that's not including the transportation costs and the energy that goes into the transportation. Okay, so what can we do with school policy? Well, we can involve the students and the staff and the administration and other stakeholders. We can form green teams. We've seen this with the Phipps Conservatory here in Pittsburgh has cooperated with the Fairfield Challenge, which is a national organization, in challenging schools and students to come up with new ideas for saving energy or for recycling or other environmental endeavors. We can establish goals and baselines for saving energy. We can connect to business plans, and we can try to communicate our goals and our policies to increase awareness in order to raise the chances of success in implementation. There's some schools and school districts have already done great work in this area. Here's one example: the Hempfield Area School District in Pennsylvania. They passed this resolution that the school board of the Hempfield Area School District sets these guidelines to ensure that effort is made to conserve energy and natural resources while exercising sound fiscal management. And they have been, they've shown a great deal of leadership in this area, and they're a good example for others. Teams of students can be created to monitor energy use and recycling programs. I saw some good examples of this in the Fairfield Challenge. You can monitor recycling. You can monitor electricity usage in different areas of the school: the gymnasium, cafeteria, auditorium, and of course the restrooms, as I mentioned earlier, with the motion sensors. Checklists can be employed. Checklists are very useful in all sorts of endeavors. You can have a student go through the school at the end of the day to check that lights are off, that computers and other equipment has been turned off. They can look at the phantom loads, check thermostats, windows and doors, check for dripping and running water in the bathrooms, and make sure that people are recycling. Rewards programs can be implemented. You can have competitions or incentives, awards. You write about people in the newsletters or on the website or in the school newspaper. You can benchmark your school with EnergySmart. If you can register your school's property and energy usage data. You can see how your school compares with other schools around the country. You can utilize EnergySmart's various resources. You can receive recognition for your accomplishments. There were almost 200 schools around Pennsylvania registered with EnergySmart as of last year. And there are other opportunities for saving money. There's opportunities in the cafeteria, the school buses, the sports and other program events, in landscaping, in the learning media, and you can have renewable energy technologies installed in the school. And of course, all this can filter into the community and the homes through energy audits. So what are some of the things that students can take home to their homes and families and their friends? Well, how to conduct a home energy audit, how to turn off unused lights and equipment and use power strips, how to monitor manual thermostats or install programmable thermostats, how to change furnace filters. These are a cheap and easy way of saving energy. How to check water heater settings so they're not too hot and wasteful of energy. How to check for leaky faucets, pipes, or whether or not you have low-flow aerators. Checking for insulation and air leaks around windows and doors, and if they're found, how to seal them. Converting from old-fashioned incandescent light bulbs to the newer LEDs or CFLs. The necessity for being responsible about recycling. Purchasing EnergySmart appliances. Planting trees in the appropriate areas around the house. And then there's information here at desireusa.org about grants and loans, rebates, and tax credits that might be available to you. So, I hope you enjoyed this presentation and learned a lot. You should be able to use some of this information to make it easier for your schools to save energy, and you can also take home a lot of this information and save energy and money in your own homes. So let's save energy and save the planet. Thank you.